So these are independent, like we said, where what happens the first time does not affect what happens the second time. The probability of dependent events is slightly different. You're going to multiply the first probability, whatever that is, times the second probability, but there's a big but here. But remember to take one of them, take away your outcomes. So I'll show you what that means. Let's look down here, and then we're going to go ahead and we'll fill in the algebra for what it says. A jar of jelly beans contains 50 red jelly beans, 45 yellow jelly beans, and 30 green jelly beans. Find the probability that both the first and second jelly bean drawn from the jar are red. Okay, so first we need to figure out what the probability of choosing. We have two pulls. We're pulling this twice. So this is draw 1, and this is draw 2. And you see I added in here knowing that the jelly bean gets eaten once it's chosen. So once you pull one of the jelly beans out, assume that you eat it. So that's going to change things. Now it's already eaten and it's not left in the jar anymore. So on the first draw, the probability that we choose a red one is going to be 50, because we have 50 red jelly beans. And we have to find out how many we have total. 50 plus 30 plus 45 tells us that we have a total of 125 jelly beans. Alright, so the first pull, we have a chance 50 out of 125 of getting a red jelly bean. Now this second draw out of the jar, we already ate it. We pulled one red one out. Assume that it actually happened. We don't know if it did or not, but just assume that it did. That's what you're supposed to do with these dependent ones. Now that we've eaten one red one, there's only 49 red ones, and there's not 125 in the jar anymore, there's only 124. So that's what they mean when they say, but remember to subtract the outcome. So now it's 49 out of 124. We can multiply those together. When we do that, we get 2,450 over 15,500. And as a decimal, that's about 0.16. Okay? So I'd say 16% chance that you're going to get two reds right off the bat. It's pretty good. It's not great, but it's kind of more than I would anticipate. Okay? All right, last one. A group of students consists of 6 girls and 7 boys. 2 students are chosen at random, one at a time. What's the probability that both students who are selected are girls? So picture being at gym class or picking teams. Once someone's chosen, they don't go back into the group. Okay? So we're picking both students chosen are girls. Okay, so we're picking a girl for the first try, for the first one, and we're hoping to get a girl for the second one. Probability of getting a girl in the first one, there's 6 girls out of 13 people. And the probability of getting a girl in the second one, now there's not 6 girls left up there anymore, there's only 5, and there's only 12 total students standing up there together. So it's going to be 6 13ths times 5 12ths. We're going to multiply that together, simplify, and we're going to get 5 over 26, which is about 0.19 or 19%. Okay? All right. We'll see you in class.